What's going on, everybody? This video is volumes of integration. We're going to look at the disk method and the shell method. Now I have another video on the disk method and shell method. It's for calculus class, not an applied calculus class, and it has more examples, goes into a little more detail, and we talk about in one of the videos disk and washer method. In this video we just talk about the washer method. We just talk about the disk method in this video. I may mention the washer method at the end of this video if you want to kind of see what that's about. All right, so let's go ahead and get started. So this video here, what we're doing is you have a function here, say y equals f of x. That's this curve right here, and what we want to do is we want to revolve it about the x-axis. So if we take this, we revolve it down here, and what it's doing is it's creating a solid, and we want to find the volume of it. So I've got the formulas here, but I want to explain to you how we get the formulas, and I think it'll help you better understand. And I want to talk about how I'm going to actually draw these things. I'm not going to draw them like I have these, and I'll explain that more also. I think the way I draw it when we're working the problems, it makes it a lot easier. All right. So what we have here, this part right here, this is a disk. And what we're doing is we're finding the volume of this disk, and we're summing them all up from A to B. You got an infinite number of disks that you're summing up. So if I were standing over here looking this way, right here, this right here, it would just be a disk. Okay, it would look like that. And what we need is the volume of this disk. So the volume of a disk, I guess you could look at it as like this. It's like a cylinder, but this thickness here, the thickness of this cylinder, it's real small. That thickness is dx. So it's kind of like you're finding the volume of a cylinder. So how do you find the volume of a cylinder? Well, it's the area of the base. Let's just draw a cylinder. So what's the area of this cylinder? It's the area of this base, which is the area of a circle, times the height, right? All right. So look at this. So if we take the area of this disk here, well, what's the area of a circle? Pi r squared, pi times the radius squared. All right, so what's the radius? The radius is from here to here. That's your radius. Well, what's the distance from here to here? We go up how many units? Y units, right? That's this, whatever this y value is. And, instead of y, we can put f of x. So the distance from here to here is f of x. And so there's your radius squared. You see that? And then times pi. You just put the pi outside the integral. Okay, and then the same thing over here. If we look at this disk here, what's the radius? That's the distance from here to here. Well, how far over do I go? That's x units. See, x squared times pi. And that's all you're doing. Now, let me show you this. I'm going to erase one of these, and I want to show you how we're going to be drawing them in the video, because I think it makes it easier. So let's just look at this one over here. So you've got your function here, right? Now, the important thing, and we're revolving it about the x-axis, but the important thing here is we need the radius. Okay, that's what we need, is the radius. Now notice how this one over here is drawn. It's drawn here, and I revolve this about the x-axis, so I draw it down here. But if you think about it, we don't really need any of that, do we? Because really all we're interested in is this distance here. The radius is measured from the axis you're revolving it about to the function. And so when you draw your rectangle in, okay, that's what this rectangle is. That's going to tell it, that's the radius. You draw that rectangle in. And so that's what we need. We need the distance from here to here, which that's f of x. And this thickness here is dx. You see that? That's your thickness. Now, it's important to draw that rectangle in because that tells us, okay, when we set our integral up, let's see, our thickness is dx, so that means our function needs to be in terms of x. And this is all going to make more sense as we're working through the examples, okay? So if you're a little fuzzy on it or a little hazy right now on what I'm talking about, just bear with me till we get into the examples, and I think it'll make more sense, okay? But that's basically all you're doing, is you're drawing your function in. You don't necessarily have to draw it in like this over here. You just need half of it because we just need this radius here. And then look, this is the same thing as when I had the other one drawn. See, if our function's like this and we're revolving it about the y-axis, well, look at this. Let's draw our rectangle in to get the radius. See, we're revolving it about the y-axis. So from the y-axis to the function, there's our radius, okay? That distance there is x. And what's this thickness? This thickness here is dy. See, it's going along the y-axis. So that tells us our function needs to be in terms of y. Okay, so we would need to know what x is in terms of y. And like I said, bear with me till we get to the examples. I just want to go over this a little bit to kind of give you an idea of what's going on. So that's the disk method. All right. Now, the other method we have is the shell method, or you'll see it called shell method, cylindrical shells. Okay, it's the same thing. And what we're doing is we have like a cylinder here, and we're getting the volume of that cylinder, and we're summing those up. Now, this one tends to give students a little more trouble than the disk method. So in order to use the shell method, we need a radius, a height, and a thickness. That's the thickness right there. All right. So let's just look at this. You see this cylinder right here? Let's just take this cylinder here. Okay. See if I can draw this. Whoop. Try to I'm not very good at drawing, so just bear with me. Okay, so that's this cylinder right here. Okay, this is your thickness right here. Okay, that's the thickness. Now, when I'm talking about finding the volume of the cylinder, I'm not talking about finding this volume in here. In other words, if you had a cylinder and you filled it full of liquid, I'm not talking about that volume. The volume I'm talking about, let's just say that we took this cylinder and we cut it right here, and then we folded it open. Okay, what would that look like? Let's see how I can see if I can draw this half decent. Okay, it would look something like this, wouldn't it? You see that? It would look like a sheet. That's what we're finding is the volume of this, kind of like if you had a rectangular solid. So what would be the volume of this? It would be this distance times this distance times the thickness here. And see, in this case, the thickness is dx. This is your height. And this right here, let's think about this. This is the length, right? This is this distance here. That's this distance around. See, if I roll it open, so that's what? That's the circumference of a circle. And what's the circumference of a circle? It's pi times the diameter, or 2 pi times the radius, right? That's the circumference of a circle. So look at this. It's, see the 2 pi times the radius, that's this. That's this 2 pi r, 2 pi times the radius. And then times the height here, and then times the thickness. That's what you're doing. So it's like you're finding the volume of a rectangular solid. All right. And so when you draw this thing, let me show you. When you draw this, so let's suppose that we had, let's just suppose, I don't know, we had something like this, and we want to revolve it about the y-axis, and we want to use the shell method. So all I'm going to do is I'm going to draw my rectangle in. That's the most important thing to draw in, is that rectangle, because that's what you're labeling everything based on, that rectangle. So I would need the radius, I would need the height, and then the thickness, which is dx. Okay, and that's what I would fill in here. All right, now notice what I did. I know I drew this a little different than what this picture is, but notice I didn't bring this over here and, you know, try to draw the three-dimensional object in. All I did is, it's just like I drew this half of it. You see that? I just drew the half of it, and I didn't even draw in the cylinder. I just drew the rectangle. Okay, I just drew this thickness here, this rectangle, because that's all you need to figure out what you're finding. Okay, now the other thing I want to point out, notice when you're using the disk method, do you see this? I know I erased the other one, but look at this. You see this? Notice when I drew the rectangle in, the rectangle is drawn perpendicular to the axis I'm revolving it about. Okay, so when you're using the disk method and you draw that rectangle in, that rectangle is drawn in perpendicular to the axis you're revolving it about. Okay, you can revolve it about the x-axis, the y-axis, and you can even revolve it about another line. It doesn't have to be the x or y-axis, and I think that's the last example will work in this video. All right, and then look at this. Whenever we use the shell method, notice I'm revolving it about the y-axis, and look how I drew the rectangle in. It's drawn parallel to the axis I'm revolving it about. So there you go. That's just something that, you know, I would just remember, because it's going to make it a little easier on you. Disk method, the rectangle's drawn in perpendicular to the axis you're revolving it about. The shell method, the rectangle's going to be drawn in parallel to the axis you're revolving it about. Okay? And just remember, this is what you've got to find for the shell method. And of course, we'll have this as volume equals 2 pi times all of this. Okay. I just wrote it out like this. I didn't write it as an integral, but you know, if we got dv to get v, we got to integrate it. Okay. And then to use the disk method, you've got to get the radius and square it and times pi. Okay. All right. So let's take a look at this example. It says find the volume of the solid generated by revolving the region bounded by y equals x squared, x equal 2, and y equals 0 about the x-axis. All right, so like the video before where we found area between curves, what did we have to do? We had to draw the graph, right? And that's what you're going to have to do here. You're going to have to sketch it, okay? Sketch the graph. So let's graph this real quick. So there's y equal x squared, okay? We're revolving about the x-axis. So let's draw my rectangle in. Now remember, when we're going to use the disk method here. So when we're using the disk method, we want to draw a rectangle in perpendicular to the axis we're revolving it about. So let's draw the rectangle in using a different color. All right. And we're going to go from, it's also going to be bounded by x equal 2 and y equals 0, where here's y equals 0 as the x-axis, and then here we have the line x equal 2. There's 2, there's 0, and we're revolving it about the x-axis. And this is really all we need, okay? All I'm doing is drawing half of this thing. Look, if I drew the whole thing, and I'm not going to draw the whole thing on all of them, but I will on this one. So there's your graph, y equal x squared. If I revolve it about the x-axis, it's going to come down like that. There's my disk drawing the whole thing. And so we're going to have something like that looks like this. All right, that's what it looks like if you draw it revolved about the axis, about the x-axis. But see, I'm just not drawing this part because all I need is the radius here, this distance from here to here. That's all I need. And so that's all I'm drawing is the top half. That's what I'm saying. Don't draw the whole thing. Just draw half of it. All right, so we also know that the thickness here is dx because the thickness of the rectangle is going along the x-axis. Now what do we need? We need, remember, this is a disk that it comes down, you know, like that, but we just need the radius. So we just need the distance from the x-axis up to here to get our volume. So the volume is going to be pi, and that's going to go from 0 to 2, say 0 to 2, and it's the radius. Well, what's the distance from here to here? We go up how many units? Y. We go up y units. Well, what is y? Y is x squared. You see that? And how come I put x squared instead of y? Well, look at my thickness. See, my thickness is dx. I'm integrating with respect to x. So I see, because it's dx, so I know however I write my radius, I need to write my radius in terms of x. And then don't forget, it's the radius squared. Okay? Okay, and that's all we did is this right up here. See, it's the radius squared. And then you got your pi out there, and it's from A to B. And in this case, A to B is 0 to 2. And so this is going to be pi 0 to 2 x to the 4th dx. And so now we're ready to integrate. So that's going to be pi times 1/5 x to the 5th from 0 to 2. And so that's going to give us pi over 5 times 2 to the 5th minus 0 to the 5th. And that's going to be 32 pi over 5. And there's your answer. So it's not hard to do. You just got to make sure that you draw the thing and just draw half of it. Okay? Let's work some more examples. All right, so here it says find the volume of the solid generated by revolving the region bounded by y equals 2x, y equals 6, and x equals 0 about the y-axis. Okay. All right, so let's just make a sketch. All right, I've got, let's see, y equals 2x. Well, that's a line that goes like this, and yes, the line continues on like this, but we don't need it. It's bounded by x equals 0, which is the y-axis, and y equals 6, which is this line here. This is y equals 6. So we don't need this. We're revolving this line here about the y-axis. So let's draw a rectangle in. Now I'm still going to use the disk method, and so let's draw a rectangle in. There it is. All right, now what's my thickness? My thickness is dy. You see that? Because that thickness is going along the y-axis. Now I need the radius. I need the distance from here to here. You see that? I need the distance from the y-axis to here. Well, what's that distance? That distance is what? X. I'm going along the x-axis, so I'm going out x units. All right. But what do I need to be in terms of? Do I need to be in terms of x, or do I need to be in terms of y? Well, look at the thickness. I need to be in terms of y. So what is x? Well, I've got y equal 2x, so x is equal to 1/2 y. All right. See, all I did is I took this and I solved it for x, because this is what? X units, but I got to be in terms of y. And so the volume is pi from what? Now, this is 0. So I'm integrating with respect to y. So that means the limits on my integral have to be y values. So I'm going from 0 to 6. And I'm integrating y over 2. 1/2 y over 2. Doesn't matter how you write it. And that's squared dy. All right, so let's see what we've got. We've got pi 0 to 6. And let's do this. Let's do pi. This is going to be y squared over 4, right? And let's bring the 1/4 out. And that's y squared dy. Okay. Remember, this would be this would be y squared over 4, right? If I squared that. And then all I'm doing, that's like 1/4. So I'm bringing the 1/4 out. Okay. All right. So this is going to be pi over 4 times, that's going to be 1/3 y cubed, and that's from 0 to 6. And so this is going to be pi over 12 times 6 cubed minus 0 cubed, and that ends up being 18 pi. All right. So you see, it's not difficult to do, and I hope you can see how important it is to sketch that rectangle in there. You've got to draw that rectangle in there. It makes it so much easier to determine that radius, to determine the radius. All right, moving right along. All right, so these next several examples, I think they're all the same. But what we're doing is we're using, like on this one, the shell method, revolving about the y-axis, then we'll do the x-axis, and then I think we'll do the disk method on this and all that stuff, and revolve this about a line. So it's going to be the same problem, but we're going to do all kinds of different things with it. Disk method, shell method, revolving it about different axes. So hopefully this will help you understand it better also. So it says use the method of cylindrical shells to find the volume of the solid generated by revolving the first quadrant region bounded by y equals 4 minus x squared, x equals 0, and y equals 0 about the y-axis. All right, so let's sketch this. So we know this is a parabola that opens downward. Okay. And why did I just draw this part? How come I didn't draw over here? And how come I didn't go below the line, below the x-axis? Well, because it says revolving the first quadrant. So I just need the first quadrant. And I'm revolving this about the y-axis, and it tells me to use the method of cylindrical shells. And look, we're going to do disk method on this also. So you'll get to see all that. So we're revolving it about the y-axis. Now remember what I said earlier. If you're using the shell method, you want to draw your rectangle in parallel to the axis you're revolving it about. And so what's my thickness? My thickness is dx. So that means my function has to be, the function that I'm going to be integrating has to be in terms of x. So let's look at this. There's the radius, right? And then I also need the height. Okay, remember when you're using the shell method, let's come up here and look. You need the radius, the height, and the thickness. Okay. And let me just show you this real quick. If we were revolving this about the axis and if I was going to draw it revolved, I would draw there. There would be the shell. Okay. And it would look something like, see, it would look something like, this is just a rough sketch. You would have something that looks like this. But see, I'm not drawing this part. I'm just drawing this shell right here. Because see, what do I need? I just need that distance there. I don't need the entire distance across here. And then I just need the height. And I can get that by just drawing this, that shell, that thickness right there, that rectangle. Okay. All right. So what's the distance from the axis we're revolving it about to that rectangle? That's x units, right? You see that? And what's the height? Well, the height from here to the top, I'm going up how many units? Y. I'm going up y units. But I've got to be in terms of x. So what's this distance from here to here? What's y? It's 4 minus x squared. You see that? I hope all this is making sense. See, I mean, all you're doing, you're finding x, y. But I got to be in terms of x, so for y, I got to write y in terms of x, and y is 4 minus x squared. And so the volume is 2 pi integral, and it's going to be the radius, which is x, times the height, which is 4 minus x squared, times the thickness, dx. Uh-oh, now I got to figure out, what am I integrating over? Well, I'm going to go from 0 to this point right here. Well, what's that point? Well, we'll have to take the 4 minus x squared, set it equal to 0. And so x is plus or minus 2. But I know this is the positive 2. See, if I drew it over here, that would be the negative 2. So I'm integrating from 0 to 2. See, we don't need the negative in this one. And so that's what I have to integrate right there. And so this is going to be 2 pi from 0 to 2, 4x minus x cubed dx. And so this is going to be 2x squared minus 1/4 x to the 4th from 0 to 2. Which that's going to be 2 times 2 squared minus 1/4 times 2 to the 4th minus, now remember what I've told you in other videos, I'm plugging 0 in. What's that? 0 minus 0 that's just all 0 if I plug the 0 in. And so when I calculate that, that is going to give me 8 pi as an answer. All right. No, and one thing I forgot to do, don't forget, all of that is times 2 pi. All of this. Don't forget to bring that 2 pi with you. I forgot to do it there also. But and I've done it in the past. Forget to bring that 2 pi. You're sitting there concentrating on integrating this thing. You just forget all about that 2 pi, just like in these problems here, and you might forget pi. Just don't forget that. I'm kind of glad I forgot it, so I would remember to mention that to you. But no, I didn't mean to forget it. So there's your answer. All right, so that was using the shell method, revolving it about the y-axis. So let's see what the next one is. Use the method of disk to find the volume of the solid generated by revolving the first quadrant regions. The same thing about the y-axis. So we're actually going to do the same problem, but we're going to use the disk method instead of the shell method. All right. And let's see the difference. Why would we want to use shell method instead of disk method? Because typically the disk method tends to be a little easier to set up. But let's take a look at that. So all I'm going to do here, I'm going to sketch it real quick. And we know we're going from 0 to 2, revolving about the y-axis, and we're using the disk method. So when we use the disk method, how do we draw a rectangle in? Well, we draw it in perpendicular to the axis we're revolving it about, right? We're using disk method. And so I've got my thickness here. My thickness here is dy. And so I need the radius. I need the distance from here to here. I need this distance right here. Well, what's the distance from here to here? It's x, right? It's x. But what does my function have to be in terms of? It has to be in terms of y. And so I've got to take y equals 4 minus x squared. And so that's going to be x squared equals 4 minus y. So x is equal to the square root of 4 minus y. See, I've got to get x, this distance here, I've got to get it in terms of y, but x is the same thing as the square root of 4 minus y. Because see, it's got to be in terms of y because of the thickness there, dy. Okay? And yes, I know it's plus or minus, but we're using the positive one. Okay? See, we're over here in the first quadrant. And so the volume is pi. And there's our integral. And it is going to be the radius, 4 minus y squared dy. All right, now let's look at this. Are we going to integrate from 0 to 2? No, we're not integrating from 0 to 2 because 0 to 2, that's the x values. What do we need? See, we're in terms of y, so we need to go from 0 to whatever that y value is. Well, what's this y value? Well, if I plug 0 in for x, I get 4 for y. So I'm going from 0 to 4. Okay? And so this is going to be pi 0 to 4, 4 minus y times dy. And so now we're ready to integrate. So that's going to be 4y minus 1/2 y squared from 0 to 4 And don't forget, all that's times pi. All right, so this is going to be pi times, that's going to be 4 times 4 minus 1/2 times 4 squared minus, and then look, when you plug the 0 in here, that's just all 0. And so our answer will be 8 pi. Well, what do you know? We got the same answer, didn't we? Whether we used the shell method or the disk method. See, I took this, I revolved it about the y-axis. I used the disk method here, used the shell method up here. We got the same answer. Okay? All right. So moving right along. Well, look at this. We're going to do the same problem, but this time, instead of revolving it about the y-axis, we're revolving about the x-axis. And we're going to do shell and disk on this, I believe. Okay. All right, so, and this one actually says by using disks, find the volume of the solid. Okay, so it's the same thing. We know this is 0, this is 2. We're revolving about the x-axis. And we're using disk, whoop, what happened there? And we're using disk method, okay? So that means that I'm drawing my rectangle in perpendicular to the axis I'm revolving it about, because I'm using disk method, right? And so, let's see, that thickness is dx, okay? The thickness is dx. And what is the radius here? That's this distance from here to here. Well, I'm going up what? Y units, right? I'm going up y. But remember, I've got to be in terms of x. So what is y? Y is 4 minus x squared. That's the radius. All right, so I've got my volume is equal to pi 0 to 2, 4 minus x squared squared dx. All right. So now, oh, look at this. We got to full that out. Remember, this is like 4 minus x squared times 4 minus x squared. We gotta multiply that out. So I get the volume is equal to pi 0 to 2. And that's what, 16 minus 8x squared plus x to the 4th dx. All right, so let's go ahead and integrate it. So I got pi times, that's going to be 16x minus 4x squared plus 1/5. Whoop, I'm sorry. That's not right. That should be 8/3 x cubed, 1/5 x to the 5th, and that's 0 to 2. All right. And so this is going to be pi times, I got to plug the 2 in, 16 times 2 minus 8/3 times 2 cubed plus 1/5 times 2 to the 5th minus, now look at this, when I plug the 0 in, that all goes to 0, so that's 0. And then when you evaluate that, punch it in your calculator, whatever, that's going to be 256 pi over 15. And there's your answer. All right. All right, so guess what we're going to do now? We're going to do the same thing, revolve it about the x-axis, but this time we're going to set it up using shell method. Okay? So use the method of cylindrical shells. Same problem, but the shell method. So let's draw this in. That's 0, that's 2. We're revolving it about the x-axis, but they want us to use the shell method here. So let's draw a rectangle in. So remember the shell method, your rectangle is drawn in parallel to the axis you're revolving it about. All right. And so here you can see we have our thickness is dy. So we know the limits on our integral are going to have to be y values. We're going to go from 0 to what? Up here to 4. Okay, because if you plug 0 in for x, you get y is equal to 4. All right, so what do we need? Let's look at this. So we need the height of the shell. We need the radius. See that? This is the radius. Okay, look, just real quick. All right, if we revolve about the x-axis, it's going to come back down like this. And so your shell would be in here like this. See, it would look like that. That's just a quick drawing. And see, I don't need this because I just need this radius and I need that height of that shell. That's what we're looking for. All right. All right, so what's that distance from here to here? Well, that's what? That's x units, right? That's x units. What's the radius here? What's that distance from here to here? That's y. But guess what? Everything has to be in terms of y, so this x value I have to get in terms of y. So once again, 4 minus... Well, let's do this. Y equals 4 minus x squared. X squared equals 4 minus y. X equals, and we'll use the positive. We're using the positive one. So this, scratch that out. That's 4 minus y, the square root of that. All right. And so the volume is not pi. It is 2 pi. Integral 0 to 4, and that's going to be the radius times the height, 4 minus y, square root of 4 minus y, times the thickness dy. All right, now look at this. How in the world do we integrate that? Do you see, I mean, we're going to get the same answer, but do you see how much more difficult this is to integrate than it was to integrate this? Yeah, I mean, we had to fold that out and do all of that. But look at this. We got y, we got square root of 4 minus y. We're going to have to use u substitution. Let's go ahead and integrate it. I'll show you. I don't know if you've integrated something like this yet, but let's go ahead and do it. I'll show you how to do it. All right, so first thing we're going to do is y times 4 minus y to the 1/2 dy. We're going to change that square root to a 1/2 power, and we're going to have to use u substitution. So u, let's do it in a little bit different color. So u is equal to 4 minus y. Du is equal to negative dy. Derivative of this is negative 1 dy. All right, so look at this. Remember, u substitution. See how I've got negative dy? So I need a negative here. So that means I have to come out here and multiply by a negative to make it negative 1. Okay? All right. So the problem we have is, yeah, the 4 minus y, we're going to replace that with u. But what about this y? I've got to get everything in terms of u. Well, what is y? Well, y is equal to 4 minus u. You see that? If I solve this right here for y. And so this is going to give me negative 2 pi. And that's going to be 4 minus u times, and look at this, the 4 minus y, I'm going to replace that with u. That's going to be u to the 1/2 du. And then I have to also change my limits. So to change my limits, well, what's u? Well, remember, you take the 0, plug it in here. U is 4 minus 0, which is 4. And u is, and then I'm going to take the 4 and plug it into here. 4 minus 4 is 0. So my limits change 0 to 4. Now, to integrate this thing, look what we got to do. We got to distribute that u to the 1/2. And so this is going to be 2 pi. Yes, I know I forgot the negative, but what I'm going to do is I'm going to swap these limits. I'm going to put the smaller limit on bottom. And remember, whenever you swap limits on an integral, it changes the sign in front, so it changes from a negative to a positive. And that's going to be 4u to the 1/2 minus u to the 3/2 times du. And so now we've got 2 pi, and that's going to be times 4, that's going to be u to the 3/2, so times 2/3, minus, that's going to be u to the 5/2, and that's going to be times 2/5, and that's going to be 0 to 4. I think I'm about going, yeah, I think I went off the screen, but I think you can see the important, I think it's just the parenthesis that's cut off. And so this is going to be 2 pi times, that's going to be 8 over 3 times 4 to the 3/2 minus 2/5 times 4 to the 5/2 minus, and then look, when you plug the 0 in, that's just going to give you 0 back there. And whenever you put that in your calculator or whatever, you're going to get 256 pi over 15. And look, you can actually calculate that in your head. That's this right here, 4 to the 3/2 is what? The square root of 4 cubed. So the square root of 4 is 2. 2 cubed is 8. That's 64 over 3. The square root of 4 is 2. 2 to the 5th is 32. That's 64 over 5, if you wanted to do that. Okay? But yeah, there's your answer. So that's that problem using shell method. And you can see sometimes the method that you use, one way is going to be a little more, one way may be a little more difficult to integrate, or maybe impossible to integrate. So if that's the case, try the other method. Okay, sometimes the disk method is going to be more difficult to integrate than the shell method. And sometimes, you know, they may be equally easy. Or they may be, both of them may be difficult. But that's why it's good to know both ways. All right. All right, so this, I believe, yeah, this is the last problem. So it says, find the volume of the solid generated by revolving the first quadrant region bounded by y equals 4 minus x squared, x equals 0, and y equals 0, about the line x equal 2. All right, so let's draw that. All right, so we've got this. That's 0. This is actually 2. This right here is your line x equal 2. You see that? That's x equal 2. This is the line that we're revolving it about. Now, what method do we want to use? It doesn't really matter. All right. So let's use the shell method. So let's draw a rectangle in right here. All right, so what do we need? We need the height of the rectangle, and we need the radius. Now remember, I don't know if you remember what I said towards the beginning of the video. Okay, so if you still watched, if you're still watching, then this is important here. Remember, your radius is from the rectangle to the line you're revolving it about. Okay? From the line you're revolving it about. All right. So let's look at this. And also we know the thickness is, we know the thickness is dx. All right. So let's first get the height of the shell. What's the height? That's what? That's y units, right? That's y units. Which is 4 minus x squared, right? And why? Let's think about this. Why did I put 4 minus x squared instead of y? Because our thickness is dx. Our function that we integrate has to be in terms of x. And then I need the radius here. So remember, the radius is measured from the line you're revolving it about to the rectangle. Well, I know from here to here, I know that's x. So what would this distance here be? Well, I know from here to here is 2, right? So this would be 2 minus this x here, right? 2 minus what's left over. And so there's your radius. And so the volume is pi. I'm sorry, not pi. It is 2 pi. And we're going from 0 to 2. See, there's 2. We got to have x values there. And that's 2 minus x times 4 minus x squared dx. And then when I multiply all that out, I get 2 pi from 0 to 2. And when you multiply that all out, you end up with x cubed minus 2x squared minus 4x plus 8 times dx. And so now we integrate, so that's going to be 2 pi times, that's going to be 1/4 x to the 4th minus 2/3 x cubed minus 2x squared plus 8x, and that's from 0 to 2. All right. And so that is going to be 2 pi times, that's going to be 1/4 times 2 to the 4th minus 2/3 times 2 cubed minus 2 times 2 squared plus 8 times 2 minus, and then I have to plug the 0 in, but we can see when we plug 0 in, all that's going to be 0. And this is actually going to give you, when you punch it all in, 40 pi over 3. All right. So this is already a long video. I know I said I might discuss the washer method, but I'm not going to do it in this video. Just go and search my YouTube channel for calculus disc washer method, I think it is. If I remember when I post this video, if I remember to put a link to it in the description, I will. But yeah, watch that if you want to see the washer method. That would be like revolving about an axis, but it's between two curves. Okay, so check that out, and I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.